We're about to show you what that code really says, and why some researchers are calling it the most important discovery in human history. According to sources inside MIT's Quantum Research Lab, the breakthrough came at 3 a.m. on a Tuesday. They'd been stuck for weeks. Classical computers kept finding nothing. Pattern recognition software failed. Even neural networks trained on every ancient language came up empty. Then, someone suggested something radical. Feed the symbols into IBM's Condor processor. Link it with Google's Sycamore Quantum Cloud. Let these machines think in ways we can't. Here's what makes quantum different. Your laptop checks passwords one at a time. A quantum computer? It checks billions simultaneously. It exists in every possibility until it collapses on the right answer. Think of it like this. You're looking for one specific grain of sand on a beach. Classical computing picks up each grain, examines it, sets it down. Quantum computing becomes the entire beach at once, then instantly knows which grain you want. The sphere's glyphs went into the quantum lattice at midnight. 3 hours later, patterns emerged. Not random patterns. Mathematical constants. The first sequence matched Planck's constant down to 15 decimal places. That's the smallest possible unit of energy in our universe. The number that defines quantum mechanics itself. The second sequence? Golden ratio spirals. The same mathematical pattern in hurricanes, galaxies, and DNA helixes. Nature's favorite number, carved into alien metal. Imagine if your phone could try every password at the same time. That's the speed we're talking about. This isn't tomorrow's technology. IBM and Google are running these systems today, right now. And they just cracked a code that shouldn't exist. For 72 hours straight, the quantum processors churned through possibilities. Each layer of symbols revealed new constants. The speed of light, the gravitational constant, numbers that hold reality together. The sphere wasn't speaking in words. It was speaking in the language of the universe itself. But here's where it gets uncomfortable for scientists. These aren't approximations. They're exact, more precise than our best measurements. Whoever made this sphere knew physics better than we do. But the ratios were just the appetizer. The real meal was hiding in the deeper code. The second layer of symbols changed everything. When the quantum AI mapped these patterns, they weren't numbers anymore. They were frequencies. Resonance patterns that made the research team stop and stare, because they'd seen these patterns before. LIGO detected them in 2015. Gravitational waves from colliding black holes. The sphere's engravings matched the frequency signatures perfectly. Not similar, identical. How does a metal ball in Colombia contain the sound of black holes colliding a billion years ago? But wait. Layer 3 got weirder. The patterns shifted into orbital resonances. Jupiter's moons dancing in perfect mathematical harmony. Saturn's rings maintaining their gaps through gravitational music. Even exoplanets we discovered last year, their orbital ratios carved into this sphere. Some physicists are calling it a cosmic Rosetta Stone. Others think it's more. Dr. Sarah Chen from Caltech put it bluntly. If you wanted to store the operating system of space-time, this is how you do it. Think about what that means. Not a message, not instructions, the actual mathematical architecture that makes reality work. The source code of existence, compressed into symbols on a metal sphere, that's not technology. That's approaching something theological. We build computers that process information. This sphere might be information, pure math made physical. The simulation results sent chills through the lab. When they modeled how the three shells would interact with those frequencies, the sphere didn't behave like an object. It behaved like a resonance amplifier, a cosmic tuning fork. Feed it the right frequency, and it would sing back the structure of space itself. Before we reveal what happened when they actually tried that, hit subscribe, because what we're about to show you has never been publicly discussed. And trust me, you'll want to hear what sound came out. Every physicist knows Einstein's quote, "God doesn't play dice with the universe." Well, maybe God doesn't need dice when the rules are already written. And maybe, just maybe, we're looking at the rulebook. Because when the team activated the resonance test, the sphere didn't just respond. It did something that violated 3 laws of physics. The quantum simulations revealed something nobody expected. Those 3 nested shells, they're not just sitting there. In the computer model, they create a field, an electromagnetic bubble that bends light around itself. DARPA's been working on this since 2018. MIT calls it metamaterial cloaking. make an object invisible by routing photons around it like water around a stone. But the sphere's design is decades ahead. When researchers modeled how electromagnetic waves would interact with those aluminum layers, the results were bizarre. Light didn't just bend, it spiraled, created interference patterns that shouldn't exist with known materials. Dr. Michael Torres from MIT's Materials Lab ran the simulation 12 times. Same result every time. The layering acts like a photonic processor. It's computing with light itself. Now, those 9 microspheres floating between the shells? In simulation, they're not random. They're positioned at precise mathematical intervals. Golden ratio spacing, Fibonacci sequence alignment. Feed the model a frequency, any frequency, and the microspheres resonate, not randomly. They create standing waves that amplify specific harmonics, like a quantum tuning fork that remembers every note it's ever heard. Remember those viral videos about Sanskrit chants making the sphere vibrate? The simulation says it's possible. Not magic, physics. Certain frequencies would create resonance cascades through the nested structure. The sphere becomes a receiver, a transmitter, maybe both. We're not saying it's alien technology, but imagine a hard drive that doesn't store files. It stores fields, magnetic fields, gravitational signatures, electric patterns. That's what these simulations suggest this thing could do. The most unsettling simulation came from Caltech. They modeled what would happen if you fed the sphere its own encoded frequencies. The ones carved on its surface, the virtual sphere didn't just resonate. It generated a localized space-time distortion, tiny, microscopic, but measurable. That's not supposed to be possible with aluminum and microspheres. Halfway through our investigation, and we've barely scratched the surface. The sphere isn't just an object. It might be a key, a tuning fork for reality, a data capsule that stores physics instead of pictures. But next, we'll show you why some researchers think those symbols aren't just equations. They're coordinates. A star map pointing to places humanity has never been. The breakthrough came when someone stopped looking at the symbols as language. Dr. Lisa Park from Harvard's Astrophysics Department tried something different. She overlaid the glyph patterns onto star maps. Not Earth's night sky, deep space, Andromeda, the Magellanic Clouds, globular clusters older than our Sunday. The match was instant. 3 symbol sequences aligned perfectly with radio burst sources. FRB 202-20319, FRB 202100807, coordinates marking the loudest cosmic screams we've ever detected. But here's what made everyone nervous. One pattern matched a source we haven't cataloged yet, a position in space where nothing visible exists, just empty darkness between Andromeda and Triangulum. The quantum AI suggests it's not empty. Something's there, waiting. Think about what we did with Voyager's golden record. We carved our address into metal. Music, math, DNA sequences. This is humanity. This is where we live. What if this sphere is the same thing? Not from here, from there. A probe carrying not just information but navigation. The ultimate message in a bottle, with a return address written in gravitational frequencies. Look